Good morning. Today we are going to be looking on the paper which was written, that is for Mathematics N4, that is for National Certificate Mathematics N4, which was written in April 2025. So let's go to the instructions. We check the paper, it's for 3 hours, having a total of 100 marks. Then we are required to answer all the questions. Then you are also required to read all the questions carefully, because if you do not read the question carefully, we might end up answering, maybe even using a wrong method as required by the question, or even maybe failing to interpret. So you have to make sure that you read all the questions carefully. You have to number the answers according to the numbering system in this question paper. So, so don't change the numbering format, the numbering system which has been given. Make sure that you number the questions accurately. Show all intermediate steps and simplify where possible. You are required to show all the necessary steps that you are going to be following to arrive at your answer. All final answers must be rounded off to 3 decimal places. If you check, all final answers must be to 3 decimal places unless it has been indicated directly for a specific question. But if there is no indication and the answer is not exact, remember that your answer must be rounded off to 3 decimal places. Then questions may be answered in any order, but subsections of questions must be kept together. So this moves with this one. You can answer in any order, but it's very important to number accordingly. And take note, they say the subsections of the question must be kept together. Then use only a black or blue pen, write neatly and legibly. So for this session, we are only going to concentrate on question 3 and question 4. We are only going to concentrate on question 3, on question 4, which is a total of 45 marks out of the 100 marks. So let's go to question 3. Here is our question 3. We are given that, here is our question 3, and we are given, they are saying solve for x, solve for x. Then you are given the equation, it's saying 2 cos squared x plus cos 2x minus 1 is equal to 0. That's what we are given. If you check here on our formula, this one is a single angle cos x, which is being squared. Then here we have a double angle. So for us to be able to solve, we need to first convert. Either both are going to be double angles or they are going to be all single angles. So we check. If you go to the formula sheet, here is our formula sheet. On our formulas, on the formula sheet, if we are to check there is no formula for double angle, meaning to say you have to be knowing that formula by heart. Kindly check, there is no formula. Here we do not have a formula for double angle. So you have to know that formula by heart. So if you go, it means that formula, you have to know it by heart. What does the formula say? The formula says that the formula says what? The formula says cos 2x is equal to 2 cos squared x minus 1. Or this formula can be written as 2 as cos squared x minus sine squared x, or this formula can be written as cos 2x equal to 1 minus 2 sine squared x. Using this formula, here you have to take note that we are dealing with solving trigonometric equation. So we have to note that to solve trigonometric equation, one method, if you cannot factorize them here, you have to make sure that all the terms are in terms of a single ratio. And in this case, we have a formula which expresses them in a single ratio, which is cos, meaning to say we were going to extract this formula here. So alternatively, it means one way, wherever there is cos 2x, that's one way. Wherever there is this cos 2x, we are going to substitute by 2 cos squared x minus 1, meaning to say it becomes 2 cos squared x plus, we are having 2 cos squared x minus 1. Then minus 1 equal to 0. Simplify there. It means we are going to have 2 cos squared x plus, take note this is quotient, this is quotient 3.1. So it's going to be plus 2 cos squared x minus 1 minus 1. Then if you are to check these first two terms, they are like terms. Don't forget to equate to 0. Those first two terms are like terms, so that one is going to simplify to 4 cos squared x. They are like terms. Then these last two terms, they are also like terms. These last two terms, they are also like terms. So it's minus 1, which gives us minus 2 being equated to 0. And then simplify. So it means our 4 cos squared x is equal to, when you transpose that, it's gonna be 2. Then divide both sides by 4. So we are now going to be left with cos squared x. So here is cos squared x is equal to 2 over 4. We are having cos squared x being equated to 2 over 4. But take note, they are saying solve that. They never said anything about the use of a calculator, meaning to say we can use our calculator in this question. Since the instruction at the page, we are also required to have a calculator. Then from here, it means we find the square root both sides so that we have cos x square root, but here it's going to be positive or negative. So when we simplify, we are going to have cos x being equal to plus or minus here square root of 2, or so that you don't make errors, you can use your calculator. It was going to give you root 2 over 2. So we are left with 2. We are left with 2 So the two solutions that we are talking about, we are having either cos x is equal to positive root 2 over 2, or cos x is equal to negative root 2 over 2. Then it therefore means the x is equal to plus or minus. We start with the general solution, cos inverse root 2 over 2 plus k multiplied by 360. That is what we got on this one. Then, or when we solve this second one, x is equal to plus or minus cos inverse negative root 2 over 2 plus k 360 degrees. Always we have to know that our k is an element of integers. Our k is an element of integers. So simplifying this, when you simplify that, it therefore means you have to go and punch that on your calculator. So our x will be equal to going to the calculator. So we are going to have plus or minus. Let's punch cos inverse root 2 over 2. So it's plus, sorry, so let's punch on our calculator. It's gonna be second function cos root 2 so it's root 2 over 2, which is giving us 45 degrees. Let's go and put a negative for the other solution, which is giving us 135 degrees. So when we come here, it means our solution is plus or minus. So it's plus or minus. Here we got 45 degrees plus k 360 degrees. Then the other side, our x, we found it to be plus or minus. When we punch this on the calculator, we got 135 degrees plus k 360 degrees. But now the question did not want a general solution. The question did not want a general solution. The question wanted a specific solution. It's saying our x is between 0 and 270 degrees inclusive. So it therefore means that we need the particular solution. We need the specific solution. So remember we said our k is an integer. So let us now substitute. If we substitute 0, we are going to start with positive 45 degrees plus k 360. So if we substitute 0, remember, we are told that x is from 0. Here it is, where we underlined from 0 to 270 degrees. X is from 0 to 270 degrees. So put that. So our x is given. You are told that is from 0 to 270 degrees. So we are now going to find the particular solutions that will lie within this range. So if we are to check, let's substitute our values. So we are going to our calculator. Our k, remember we said is an integer, meaning to say it can either be positive or negative integer. So number one, let's substitute 0. If we are going to start by 45 degrees. So if we say 45 degrees plus, let's start with from -1. So plus, where there is k, if we put a -1, then the 360, sorry, let's put the k at the end, let it be 360 times k. So our k, we said let's put -1. We are getting -315 degrees, which is outside the range. Let's substitute 0 where there is k. If we substitute 0, we are getting 45 degrees. And as you can see, the 45 degrees is within the range here. So one of our solutions is 45 degrees. Let's go and substitute 1 where there is k. We are getting 405, which is outside the range. So here we got 45 degrees. Now let's go and use the one which is having minus 45 degrees plus, because we started with the one with. So if we use that, let's substitute 1. What are we going to get? It's 315, which is outside this range. Let us substitute 0. As you can see, it's again -45 degrees, which is outside the range. Let us go and substitute a -1. It's -405, which is outside the range. So using this solution, we only got an answer which is 45 degrees. Then we go to the alternative. So there we are going to start with the positive 135. So we are going to put 135, which is positive. When we substitute -1, we are getting -225, which is outside the range. Let's go and put a 0. We are getting 135, and 135 is between here. 135 is between here. So already we now have 45 and 135. Let us substitute 1 where we put a 0 there. We are getting 495, which is out. Now let's go and use -135. If we use -135, we are getting 225. 225 is also within this range. So it's a third solution, 225. Let us go and check. If we substitute 0, it's outside the range of this given. Then let us substitute -1. We are getting 495, which is outside. So our answers, which are within the range, we found our answers, which were our x, is equal to 45 degrees is within the range, or our x is equal to 1, 35 degrees, or we found that our x is equal to 225 degrees. These are the three solutions to the equation. Then that's the equation. And can you please take note, alternatively, so we are going to say or starting from the equation that we are given, we can rearrange that equation to get 2 cos squared theta minus 1 plus cos 2 theta. That was the alternative way. So as you can see, this is equal to 0. Then as you can see, this part 2 cos squared, this part 2 cos squared x minus 1, 2 cos squared, it can be equated to cos. Take note here, it's cos, not co. Can be equated to cos 2x, meaning to say, from here, this part, we are going to put cos 2x, then plus cos 2x equal to 0. If we are to check, these are like terms. These are like terms. So you'll be left with 2 cos 2x must be equal to 0. Then from there, we are going to be left with dividing both sides by 2. If you come divide here by 2, divide here by 2, we'll be left with our cos 2x being equal to 0. So eventually it means that our 2x will be equal to plus or minus cos inverse of 0 plus k 360 degrees. Always remember that k is an element of integers. So when you use the calculator, cos inverse 0 means we are going to have our cos inverse 0. So it's going to be shift cos 0 equal to 90 degrees. 90 degrees. So it means we are going to get our solution as plus or minus 90 degrees. So this will be given as 2x is equal to plus or minus 90 degrees plus k 360 degrees. Then from there, we are solving for x. It means we are going to divide throughout by 2. If we divide by 2, so our solution is now going to be given as x is equal to plus or minus 90 degrees plus, it's no longer 90. When you divide the 90 by 2, it's going to be 45 degrees plus k. When you divide the 360 by 2, is going to give 180 degrees. So using this solution, we now want the particular solution based on our, we are told x is in the interval from 0 degrees up to 270 degrees. So we now want the values of x. Using this general solution, we can now go to the particular solution. We go to the calculator. So on our calculator, as you can see, we are going to substitute our k. It's any integer. We highlighted that our k is an integer. So it means we are going to start with positive 45 degrees. So we are going to say 45 plus 180 degrees. Let's take our k to be -1. We are getting -135. This is -135, which is outside this range. Let's go and substitute a 0 there. We are getting 45, and 45 is lying within the range. Let's go and substitute a 1 there. We are getting 225, and we are seeing 225 is within the range. Let's go and substitute a 2 there. So if we are to check, a 2 is outside the range, so we are going to leave out the 2. We are going to leave out. So we only accepted 35. So we only accepted 45 and 225. Now let us use -1. -45, the second solution, which will be -45 plus. So -45 plus, which is 2, we see is 315. 315 is outside the range. Let's go and put a 1 there. If we put a 1, we are getting 135. 135 is within the range. So we now have 45, 225, then 135. Let's us go and substitute a 0. If we substitute a 0, we now have -45. -45 is outside the range. So eventually, our answers, we managed to get our x. So you have to take note, eventually, we got our x equal to 45 degrees. We got our x equal to 225 degrees. We also got our x equal to 135 degrees. Then let's go to the next question. (3.2) is saying determine 1 over cosec 75 degrees without using a calculator. So 3.2, let's create our space for 3.2. Okay, said 1 over cosec 75 degrees. So we are going to have 3.2. They said 1 over cosec 75 degrees. 1 over cosec 75 degrees. But we know that, check on our formula sheet, we do not have the formulas which are talking of cosec there. We do not have them except this one. But you have to know. We have to know that cosec here, you have to just know that cosec theta, it means 1 over sine theta. It means cosec theta means 1 over sine theta. So using that, we can now go here. It becomes 1 over, but over means divide. Divided by 1 over sine theta. So this one changes to 1 multiplied by sine theta. Take note there, our theta, the angle, there, we have it. We have that angle. The angle is sine 75 degrees. So here it's sine 75 degrees over 1, which is equal to sine 75 degrees. So it means this is equal to sine 75 degrees. But now we are required to simplify this without using a calculator. It therefore means you have to link special angles. The moment you are required to simplify without using a calculator when dealing with trigonometry, firstly think in terms of special angles. So which special angles can we combine to get 75? It means this can be written as sine 45 degrees plus 30 degrees. 45 plus 30 gives us 75. But now, we are now having compound angle. We have to go to the formula sheet, extract the formula for compound angle, sine, which is here. Then we check plus is on top here, so we are going to take plus there. This is the formula that we are going to utilize, and we are going to utilize the one with plus because now we are using plus. We are using plus on our question. So it means this can now be written as sine. If you check, we copied this from a formula which is saying sine A plus B is equal to sine A cos B plus cos A sine B. So using this is the one which is first A. So it means our A in this case is 45 degrees. Then B is the one which is on the second part. Here is 30 degrees. So our B is 30 degrees. So using this formula, it therefore means we are going to end up having sine 45 degrees cos 30 degrees plus cos, simplifying, plus cos 45 degrees sine 30 degrees. You are supposed to be knowing these trig ratios for special angles, these ratios for special angles by heart. But if you are not remembering them, you can still derive them in the exam. For example, 45, it means you are going to use an isosceles right-angled triangle. Yeah, we can simplify it this way. Then we can just put one here, one there. So if you check, because we said it's isosceles here, it means this will be 45 degrees. This will be 45 degrees. Then here, if we use Pythagoras theorem, it means solving this side, we end up having root 2 there. So how does it go? How is it going to say sine 45 opposite over? So you'd realize that sine 45 degrees is equal to, if we use this 45, this becomes the opposite over hypotenuse, which is root 2. If we are to simplify that, to rationalize the said, it's going to, you multiply both the numerator and the denominator by root 2. That is, if you decide to put it rationalized, remember this question said without using a calculator, it means you have to multiply both the numerator and the denominator by root 2. So if we say 1 times root 2, we are going to get a root 2. If we say root 2 times root 2, it's going to be 2. Meaning to say, where we are having sine 45 there, it means it changes to root 2 over 2. Then, if we want cos 45, the cos we know is adjacent, taking our 45 here, adjacent over hypotenuse. So cos 45 degrees is equal to adjacent, which is again 1 if we use this one as our reference angle. So adjacent is this one over root 2. And if we were to rationalize multiplying both the numerator and the denominator by root 2, 1 times root 2, which is root 2 over this times root 2 times root 2, it gives us 2. So it means cos 45, we are also going to substitute root 2 over 2. Now, if we want cos 30 and sin 30, again, they are special angles. We are expected to know that by heart. But if you don't remember them, you can still come up. So if I'm to use an equilateral triangle, I'm going to be having an equilateral triangle here, where I will say 2, 2. From here, I drop a perpendicular, and we know that for an equilateral triangle, a perpendicular from the vertex will bisect the third side, meaning to say here it will be 1, here it will be 1. Since it was equilateral triangle, it means here was 60 degrees, here 60 degrees, here 60 degrees, here 60 degrees. So this perpendicular bisector, it also bisects the angle. We are now having a 30 degrees. So we can use Pythagoras theorem in one triangle to calculate this perpendicular height. It's going to give us a 2 squared minus 1 squared root of that, which is root 3 here. So cos 30 degrees, we know 30 is adjacent over hypotenuse. So cos 30 degrees will be equal to adjacent, which is root 3 over hypotenuse 2 here. So it's going to be root 3 over 2. Then for sine 30, sine, we know it's opposite. So sine 30 degrees is equal to opposite, which is 1, over hypotenuse, which is 2. Sine 30 is half. And take note, I'm repeating these special angles, the ratios of special angles, you are expected to be knowing them by heart. So when you simplify this, it's going to be equal to root 2 times root 3 is going to give us a root 6 plus root 2 times 1, which is root 2. Take note, here our denominator here was 4. Here our denominator on the other ones is 4 again, which is 2 times 2. Since our denominators are the same, this can be written under one denominator as root 6 plus root 2 all over 4. This becomes the answer for 3.2. Then let's go to the next question. That 3.3 is saying simplify as far as possible. So we need to erase all this. Let's erase all that part. So we are going to question 3.3. So we write 3 0.3. The question is saying what? Sine 90 degrees minus theta, which is multiplying cos 180 degrees plus theta plus tan theta. We are having tan theta, which is multiplying a cos theta. Then we are having sine theta minus 180 degrees. So for us to be able to answer this type of question, you need to understand the cast diagram. You need to understand the cast diagram. So if we are to put the cast diagram here, we need to understand we have 4 quadrants: 1, 2, 3, 4. From those 4 quadrants, we have to know that this terminal is 0 degrees, and going in a anti-clockwise direction, here it will be 90 degrees, here it will be 180 degrees, coming here it will be 270 degrees, here it will be 360 degrees. And we have to know that when we are counting going anti-clockwise way, our angles are positive. The moment we are going in an anti-clockwise direction, our angles are positive. Then you also have to know that when we are going in a clockwise direction, our angles are negative. So if we are to go in a clockwise direction, it means here it's 90 degrees. Then here we are now going to have a negative 90 degrees. Then here it becomes a negative 180 degrees. Then here it becomes a negative 270 degrees. When we complete revolution, we are now going to have a negative 360 degrees. So, and we have to know that in the first quadrant, all our ratios are positive for first quadrant. In the second quadrant, you have to know that, or in the second quadrant, we have to know that sine theta is positive, cos theta is negative, tan theta is negative. Then when you go to third quadrant, we have to know that sine theta is negative, cos theta is negative, then tan theta is positive. Then when we go to the third quadrant, to the last quadrant, the fourth quadrant, you have to know that sine theta is negative, cos theta is positive, then tan theta is negative. So with this diagram, we can simplify this. So if we are to check when answering this type of question, we have to look at ratio by ratio. So the first, we are going to look at this ratio as it is, only the first ratio. So if we concentrate on the first ratio there, what are we going to say? You have to ask yourself 3 questions on each ratio. First question is going to be, where is 90 degrees minus theta? So if we are to check 90 degrees, we said this terminal, and we said minus, it simply means you are going in a clockwise direction, and we always be assuming that theta is an acute angle. So 90 degrees, then we take minus theta. So it means we are entering in the first quadrant. we identified the quadrant. Then we ask ourselves, what is the sign of sine in the first quadrant? What is the sign of the ratio that we are dealing with? What is the sign of sine in the first quadrant? So we are realizing that sine, we said it's positive in the first quadrant. Then the last question, will our ratio change or it will not change? So in this case, our ratio will change. Your ratio will only change when we are dealing with 90 degrees or 270 degrees. So therefore here it's going to be 90. So it's going to change to cos. So it means it's going to be positive cos theta. The resultant is going to be positive cos theta. So, okay, let's go to the second ratio. The second ratio, let's mark it, is this one here. So ask the questions. Number one, we are going to ask, where is 180 plus theta? So we go and check. There is our 180. And remember, we said angle is plus when we go in an anti-clockwise direction. So starting from 180 there, so we are going to have our plus in R. And remember, we said theta is acute plus 180 plus. So we move in a anti-clockwise direction because we say plus. So where are we having our angle? Our angle is in the third quadrant. So in the third quadrant, what is the ratio? What is the sign of cos? We see it's negative. Will it change? No, because we have 180. So it means this ratio is going to change to negative cos theta. Then we are going to have our plus. Where there is sine, where there is tan, we change the ratio to its quotient equivalence. We know that sine tan theta is always equal to sine theta over cos theta. So when you see tan, it's advisable that we change this ratio for tan to there. So it means that tan is going to change to sine theta over cos theta, which is going to multiply this one, cos theta. If we are to write it in fraction form, is the same. Okay, cos theta here. But if we, because we now have this term as a fraction, if we are to write this in fraction form, it means it must be cos theta over 1. Then we are going to multiply. Then here we are having theta minus 180. So if you check, we know that our angles, we normally start with the number. So it means this angle can be written as minus 180 degrees plus theta. So where is 180 degrees? We just check what negative 180 degrees is in the negative 180 degrees. Here is the line. Then we are saying plus theta plus, we are going in an anti-clockwise direction, meaning to say it's going to go that we are going to be in which quadrant? We are going to be in the third quadrant. And what is the sign of sine in the third quadrant? It's negative. Then is the ratio going to change or not? It will not change because we are dealing with 180. So here we are going to have negative. This one, it changes to negative sine theta. So we have simplified that. We have simplified that. So it would therefore means that we now need to simplify this further. If you check this term, it's a denominator. This one and this one, it's a numerator. So these are going to divide and we get 1 there. So it will mean that when we simplify this further, we are going to end up just getting cos times that, it's gonna be equal to negative cos squared theta plus here sine theta, but this sine theta is going to multiply a negative sine theta. So it's gonna be a negative sine squared theta, which is equal to, we are going to factor out a negative 1 here, which is common. So we'll be left with the cos squared theta plus sine squared theta. If we go to our formula sheet, we have a formula there. Which is having cos squared theta plus sine squared theta. Here is the formula. It's saying sine squared theta plus cos squared theta is equal to 1. So it will mean that we are now going to have our answer here, where there's cos squared theta plus sine squared theta, it's 1. So negative 1 times 1, our final answer is going to be equal to negative 1 here times this bracket is 1. So our final answer is negative 1. Then we go to the next question. Let's go and check what the next question is saying. It's saying prove that sine. So let's create here. Let's create space here. Let's create a space there. So if we are to create space, we are going to have the question for 3.4. It's saying sine is 3.4. It's saying sine 315 degrees tan 210 degrees sine 190 degrees all over cos 100 degrees sine 120 degrees is equal to, saying proof that is equal to negative root 2 over 3. So it means for us to prove this type of thing, it's better we take the complex part, which is the left-hand side here. So we are going to take our left-hand side. We write that it's sine 315 degrees multiplied by tan 210 degrees multiplied by sine 180 190 degrees all over cos 100 degrees sine 120 degrees. So simplifying that, for us to simplify this type of questions, we need again to understand our cast diagram. So using the cast diagram that we have drawn earlier on, this is our cast diagram, and we, on top of what we have learned so far, or on top of what we have known so far, you are supposed to know the general format of the angle that you expect to find in each quadrant. So here it means we can expect to find angle like theta. Remember, we said our theta is acute. or 90 degrees minus theta. When we come here, remember when you go here, it's plus. So it's 90 degrees plus theta. Of reading from here going there, it will be 180 degrees is clockwise minus theta. Then here we expect 180 degrees plus theta. Then here we expect one from, if we read from here, so it's 270 minus 270 degrees minus theta. Then in the fourth quadrant, minus theta, then 270 degrees plus theta, then 360 degrees here minus theta. These are the types of angles that we expect in each quadrant. So we are going to answer this question. How are we going? We look at angle by angle. So we are going to look at this. First, we look at ratio by ratio. So we are going to ask here, 305 is in which quadrant? If you say 305 is greater than 270 but less than 360. So it's in the fourth quadrant. Fourth quadrant, how can we write an angle? We just choose one. So 360 minus. So here to get 315, it means it's 360 degrees minus 45 degrees. Remember we said this must be acute, minus 45 degrees. So we now see it's in the fourth quadrant. What is the ratio? What if the sign of sine in the fourth quadrant? We found it to be negative. Then would the ratio change or not change? We used 360, so it will not change. So it means this is going to reduce to, we take the negative, so it's gonna be negative sine 45 degrees. Then we go to the next one. It's saying 210 degrees. That is the next. So let's concentrate on this next one. Tan 210. So 210, the angle is in each quadrant is between 180 and 270. So it's in the third quadrant. How to write an angle in the third quadrant? You just choose one. So I'm going to choose 180 plus. So if it comes here, this can be written as 180 degrees plus what to arrive at 210? It's plus 30 degrees. So 180 plus, ask what's the sign of tan in the third quadrant? It's positive. Here it is. It's positive. So it means this is going to change to positive 30 degrees. So we are going to do that, positive 30 degrees. It's going to be positive. Then our ratio is tan. So it's positive tan. It's positive tan 30 degrees. We go to the next one. If we check the next one, this is the ratio that we are having. Then we are having 190 degrees. 190 is in which quadrant? Is in the third quadrant. Is between 180 and 270. How do we write an angle in the third quadrant? It's gonna be 180 degrees plus. It's going to be plus what? To get 190. So it's gonna be plus 10 degrees. Then what's the sign of sine in the third quadrant? We see it's negative there, negative. So already here we are going to put our negative. Will the ratio change or not? It's not going to change because we are dealing with 180. So it's gonna be negative sine 10 degrees. Then we go to the denominator. When we go to our denominator, here, cos 100. 100 is in which quadrant? If we check, it's between 90. From our cast diagram, 100 is between 90 and 180, which is the second quadrant. How do we write an angle in the second quadrant? We choose from those two, but always remember you link. So we are here. We are now here. So we are saying the 100. How do we write the 100 degrees? It's in the second quadrant, either this or this, but we want to link. There's a 10 degree there, so that will be guiding us, meaning to say it's gonna be 90 degrees plus 10 degrees there. So 90 plus 10 degrees is going to give us what? The 100, which is here. So we identify in the second quadrant. What is the sign of cos in the second quadrant? What is the sign of cos in the second quadrant? We found it to be negative there. So it means this reduces to a negative. Then will the ratio change or it will not change? It will change because we are talking of 90 plus, and we said 90 plus, we talk of co-ratio. So the ratio changes to sine. Which angle now? That acute. Remember, we said we assume theta is acute multiplied by, we go to sine 120. 120 is in which quadrant? If you check, 120 is in this quadrant. Which one can you use? You can use any of the two in the second quadrant. There's no problem. So we can decide to still use here. Take note, we are now on this one. So we have to know that 120 degrees, we can write the 120 as what? If you decide to use 180, it means it's going to be 180 degrees minus what? Minus 60 degrees. So to get 120. So it's in the second quadrant. What's the sign of sine in the second quadrant? We found it to be positive there. We found it to be positive. So it means here it's going to be positive. The ratio will change or not change because we are having 180. So the ratio is not going to change. So we are going to have a positive sign. A positive sign 60 degrees. Then from there, we can simplify further. This will be equal to, this is going to give us negative sine 45. 45, remember, it's a special angle. We have simplified those earlier on. Negative sine 45, we can just go and check. We said sine 45 is what? If you still remember, sine 45, we found it to be root 2 over 2. Sine 45, we found that one to be root 2 over 2. So we just have to use that. So it's going to be negative root 2 over 2 is going to multiply a tan 30 special angle again. Since we had not calculated it earlier on, but if you still remember, we have our triangle tan 30. We know from our trig ratios, tan can be written as opposite over adjacent. So it means tan 30 degrees. With 30 degrees, the opposite is 1. So this can be written as 1 over adjacent of 30 degrees is root 3. But if you want to rationalize this, multiply the numerator by root 3, it's going to be root 3 over, multiply the denominator by root 3, it's root 3 times root 3, which is going to give us root 3 over 3. So that becomes our tan 30 degrees. It's root 3 over 3. So you just go and put that. It's root 3. For tan 30, it's root 3 over 3. Then, if you check on our numerator, we are having this, which is minus sine 10 degrees. On our denominator, we are having minus sine 10 degrees there. So those ones are going to divide each other to get a 1. Then we simplify the sine 60 there. Again, 60 is a special angle. How are you going to simplify that? So it means it's going to be, how to simplify that? We just make it go to the triangle. We want sine 60 degrees. So on our triangle, we can determine sine 60 degrees. So here, it will therefore mean that our sine 60 degrees will be equal to, here is our 60 degrees. What's the opposite of 60? It's root 3 divided by the hypotenuse. We are using trig ratios. We are using trig ratios. Sine is equal to opposite over hypotenuse. Cos is equal to adjacent over hypotenuse. Tan is equal to opposite over adjacent. This is what we are using to simplify that. So it will simplify. So sine 60 is opposite of that over the hypotenuse, which is 2 there. Then we are going to get our answer. So what did you get there? Root 3 over 2. Let's go to that one. So here we are getting root 3 over 2. This now can be written as minus root 2 over 2 multiplied by root 3 over 3. The over means divide. So let's say divided by root 3 over 2. And take note, this one was our numerator. So we can simplify that. So it's going to be equal to, eventually our answer is going to be equal to negative root 2 over 2 times root 3 over 3 here multiplied by, this one changes the moment we change the sign there, it becomes 2 over root 3. And as you can see here we are having a denominator of 2. Here we are having a numerator of 2. They divide each other to get a 1. Further on, if you look here we are having a root 3 here on the numerator. Here we are having a root 3 on the denominator. They divide each other to get a 1. So eventually our answer is going to be equal to negative root 2 here divided by a 3. And conclusively, we can see that our left-hand side is equal to our right-hand side as required by the question. Right. Kindly take note that when we were simplifying question 3.4, the question did not specifically say without using a calculator. So when we were having the acute angles, it's possible that you can just simplify using your calculator. Then let's go to question number 4. Question number 4, on question 4.1, they are saying, given fx is equal to, so What are we given? That is question 4.1. Given that fx is equal to x cubed minus 2x minus 4. This is what we are given. Given that fx is equal to that, then the question is saying, use differentiation. Using differentiation, calculate the coordinates of the turning points and the points of inflection, and also distinguish between the maximum and the minimum turning points by using the second derivative. By using the second derivative. So first step, let's calculate the coordinates of the turning point. To calculate the coordinates of the turning point, step 1, we have to get the first derivative, and always know that, don't forget the correct notation. So we bring down the power. So it's going to be 3x. Then on the power, we subtract 1. So we are applying the rule which says if you are given that y equal to a x to the power n, to get the derivative, which we can denote as y prime, this means you take the coefficient as it is there, then bring down the power, then we have x to the power n minus 1. If we are to check, let's go here. The formula that we are using is the formula that we are having on our formula sheet. Here it is. Here it is. You are using this one. If y is equal to ax to the power, and then the derivative will be equal to k a, what's given there? What's given here? This is the formula that we are applying to simplify there. So it therefore means here we are going to have that. So it's gonna be 3x. Then when you subtract, it's gonna be to the power 2. Then here it's gonna be minus 2. This becomes our derivative. Then we have to know that at turning point, because they said at turning point, we have to know that at turning point, the derivative is equal to 0. So we have to equate that to 0. Our 3x squared minus 2 is equal to 0. Therefore, our 3x squared is equal to a positive 2. If we divide both sides by 2, here dividing both sides by 3, here divide here by 3, divide here by 3, we are left with our x squared being equal to the square root of 2 over 3. Sorry, being equal to 2 over 3. X squared being equal to 2 over 3. Then from there, we are solving for x. We are solving for x, so it means we have to find the root both sides. So root to here, root to the other side. Then we have to have plus or minus there. So we are left with x squared x equal to root 2 over 3, or x equal to minus root 2 over 3. Then the question wants coordinates, not only x coordinates. So when you get the x coordinates, substitute them in the original function. So it means we are going to have our fx if x equal to positive, which is 2 over 3 root. Our y, which is the corresponding y coordinate, will be equal to, substitute that. So where there is x, we are going to put 2 over It's root 2 over 3. It's gonna be root 2 over 3 squared minus 2 multiplied by root 2 over 3 minus 4. Then, if it's negative, if y is equal to, if x is equal to a negative root 2 over 3, so it means y will be equal to root negative 2 over 3 cubed minus 2 negative root 2 over 3 minus 4. Then with this, we go back to our calculator. If we go to our calculator, we are going to get so first one, we are going to put root 2 over 3. So it's 2 over 3. Take note, it's cubed, not squared. That cubed minus 2 then root 2 over 3 minus 4 the answer we are getting is minus 36. The answer we are getting here is minus 36 minus 36 plus 4 root 6 over 9. Minus 36 plus 4 root 6 over 9. Then when we are substituting the negative 1, it therefore means we are going to substitute a negative there. Then a negative there. We are going to get minus 36 plus 4 root 6 over 9. So eventually, it will therefore means our answers here, we got minus then 36 plus 4 root 6 over 9 Then the other one we get minus 36 plus 4 root 6 over 9. These are the answers. But if we go back to the instruction here, it was saying all final answers must be rounded off to 3 decimal places unless indicated. So it means these answers must be to 3 decimal places. So when we go to our question, we have to put these answers to 3 decimal places. So it will mean that here our x, we are going to go to our calculator. So going to our calculator, we are going to see this one. If we put it to 3 decimal places, the answer is going to be 2.91, negative 2.911, negative 2.911. That is to 2 decimal places. And when we go to the other one, let's go to so this one, delete. Then we go remove the other one. We delete other one there. If we are to change that, it's giving us negative 5.08, negative 5.089. Take note, for us to round off, it means this third digit. 1, 2, 3. So we concentrate on this fourth is greater than 4. So we add here. So we get 0, 8, 9 there. And we have to take note again on our x values, root 2 over 3. So that one was going to be equal to root 2 over 3. That one. So it's 0.816 when we round it off, because this one is less than 5. So we maintain these 3, 0.816. 0.816. So writing our answers there properly, we are supposed to have, because the question wants to 3 decimal places, so it therefore means here for our x values, you have to take note there. For our x values here, so our x is equal to, for this one, to 3 decimal places is 0.816. And for this other one, which is negative, it means it's gonna be negative 0.816 to 3 decimal places. Then when we go to these answers, this one is gonna be negative 5.089. Then this one is gonna be, this is the y. This is the y. Negative 2 point, so it's negative 2.911. Therefore, if we are to write now the coordinates of the turning point, therefore, coordinates of turning point, because that is what was required, coordinates of turning point, we are going to have, if we substitute this, which is positive 0.816, it's going to move with negative 5.089, then and The other one, we are having a negative 0.816, which is going to move with that one is going to move with negative 2.911. Bottom line, you just have to know that to get the coordinates of turning point, the steps, let's just summarize that one. To get the coordinates of the turning point, we said the steps that we have to follow. I'm now summarizing. Number one, get first derivative, meaning to say we have derivative, differentiate the given function. Number two, equate the first derivative to 0, equate first derivative to 0. Number three, solve for your variable. Solve for your variable. In this case, we were solving for x after equating to 0. Once you get the x values, substitute x values obtained in original or given function. To get the corresponding y values, lastly, write your answer as coordinates. Write your answer as coordinates. Write your answer as coordinates. These are the steps that you have to follow to get the coordinates of turning point. Then remember, it's saying we are still on that question, saying use that coordinates, calculate the coordinates of turning point. We have them. What's the next? They want the points of inflection. Points of inflection. So to get the point of inflection, it means we have to get the second derivative and equate to 0. So let's go there. So we now have coordinates at turning point here. So we are moving on to the next step. Let's go to the next step. So we want the point of inflection. So to get the point of inflection, it's continuation of this question. Number one, you have to get the second derivative. And the second derivative, we are going to differentiate. So bring down the 2 there. It's going to be 2 multiplied by 3 multiplied by x to the power 2 minus 1. So eventually it's going to be 6x. Our final answer is 6x. Number 2, equate that second derivative to 0. We are saying at point of inflection, the second derivative is equal to 0. So it means 6x must be equal to 0. Then dividing both sides by 6. It therefore means the x is equal to 0. Once we get the x value, substitute this x value in the original function. So it means to get the y, we substitute when? We substitute x 0. So the y will be equal to 0 cubed minus 2, 0 minus 4. So our y is equal to negative 4. So the point of inflection coordinates of point of inflection will be given by 0, negative 4. Now let's take note what are the steps to get the point of inflection? What are the steps to get the point of inflection? Number one, to get the point of inflection, number one, always know that determine the second derivative. How? It means you have to differentiate the first derivative. Number two, equate second derivative to 0. Equate second derivative to 0. Number three, solve for variable. We are solving for the variable. In this case, it was our x. When you get the x value, substitute the x value obtained in the original function, in the original or the given function. Then from there, remember to write your answer as coordinates. Write your answer as coordinates. Then let's go to the question. What again was needed? And also distinguish. Let's go to that. The last part. They sing and also they are saying and also distinguish between the maximum and the minimum turning points using the second derivative. So using that, to distinguish that, it means we have to substitute the coordinates that you obtained. Let's go. So to do that next step, you want to determine. So you get your second derivative. We found our second derivative to be equal to 6x. This is the second derivative that we get. So to determine, substitute the x values at turning point. If the value that you get for second derivative, so when x is equal to 0.816, it means the second derivative will be equal to 6 multiplied by 0.816. Since the answer that you got here is positive, since the answer that you are going to get here is positive, it therefore means this is a minimum point. So it means the point so it will mean that the point 0.816 with negative 5.089. It will mean this one is minimum point. It's a minimum turning point here. Then we substitute the other x value. So if we are to substitute the other x value, it means here we are saying when x is equal to negative 0.816, if we substitute it in our second derivative, we are going to get our second derivative. Take note here. Take note here. This one was supposed to be f 0.816. Here it's f, which is negative 0.816. There it's going to give us 6. Then we substitute a negative 0.816. If you check the answer that we get when we simplify here, it's negative. So since this answer is negative, it follows that the point negative 0.816 is to negative 2.911 is a maximum point. This point is maximum point. Then, so when you substitute the x value at a turning point in the second derivative, if the answer that you get is a positive, it means that point is a minimum. And if the answer that you get is a negative, it means that point is a maximum. Then we go to question 4.2. So to simplify question 4.2, let's just create some space here. Let's try to create some space here. So it simply means here. Right? The question is saying given y is equal to, so that's 4.2. 4.2, it's saying y is equal to square root of quot x. So it's saying differentiate using the chain rule. Differentiate using the chain rule. So if we are to check, we go to our formula sheet to check here, this is where the chain rule is. We are going to apply the chain rule. Here is here is the formula for chain rule. Here it is. That's the formula for chain rule there. So applying that formula, it simply means we go to our question. Then we are going to say let u be equal to quote x. So du dx will be equal to, you can do it, but just go to your formula sheet. Here is our formula sheet. They said here, if y is equal to quote x, here, we are going to borrow here. If y is equal to quote x, the derivative, the first derivative of quote x, it's negative cosec squared x. It's negative cosec squared x. So, negative cosec squared x, you just go with that here. So it means to differentiate this, it's going to give us negative cosec squared x. But remember we said let u be. So it means our y there will be equal to square root of u, because here we said let this be u. So it means this y can be written as x to the power half, which is x to the power 1 over 2. So it means dy, it therefore means dy, not x. Let's go back. It's u here to the power 1 over 2. We are applying the laws of indices. The rule which says here, we applied the rule which says square u a to the power half is equal to the square root of a. This is the law that we applied there. Then from there, we can now differentiate. So dy du must be equal to, bring down half. Then we are left with u to the power half minus 1, which becomes a negative half. Remember what we did there? We applied the theorem. From here, we said, therefore, dy du will be equal to, the coefficient there is 1, bring down the power, which is half, then multiplied by u to the power half minus 1. This times this, that's how we got half, then how we got. So this is that. Then once you get this, it means we can simplify. The question wants us to get dy dx. So it means our dy dx will be equal to dy times du multiplied by du divided by dx. So dy du, we found it to be half multiplied by u to the power a negative half times du dx, we found it to be a negative cosec squared x. So it means if we are to write this, it can be written as, let's write that here. Let's write this, proceed with it here. So it means this will be equal to half, it's 1 over 2 u to the power half. When you shift it to the denominator, the sign of the power changes. So we changed the power to be positive, multiplied by a negative cosec squared x. So this will be equal to a negative cosec squared x all over 2, what's u? It's cot x to the power half, meaning to say this will be equal to a negative cosec squared x, a negative cosec squared x divided by 2 root cot x. Take note here, we applied again this. Here we are coming from exponents to sets. We are having a half, we introduce a square root. So where we are having to the power half, we converted it to be here. So this becomes our final answer. This becomes our final answer. Then we go to the next question, saying differentiate with respect to y. Differentiate with respect to y. So what are we having? Let's erase here. So we are going to question 4.3. So it's going to be x equal to 1 over cube root of y minus 1 over cosec 2y plus ln y minus e to the power a negative 2y all over 4 plus 5 to the power 3i y all over 2 minus p I to the power 0 plus 6py. So we are required to differentiate that with respect to y. So to differentiate that, it therefore means we have to make sure that each and every term is already in a form that it can be differentiated. So if we are to check, we check term by term. So here we are going to check, can we differentiate this? We can't. So it means our x here will be equal to, convert that, it becomes 1 over, instead of that, we are going to apply the rule which says that the nth root of a number, we can convert that number to be a to the exponent of 1 over n. So using that, it means this can be converted to 1 over y. So 1 over y to the power 1 over 3. And take note, the reason for converting, we cannot perform differentiation when we are having a said form, we need to convert to the exponent. That's why we could not differentiate. Then minus, we go to the next term. We know cosec. Here, we know cosec y is equal to 1 over sine y. So if we say 1 over cosec, 1 over cosec y, it means this will be equal to 1 divided by 1 over sine y, which becomes 1 multiplied by sine y over 1. Meaning to say this will change to a sine y. Therefore, using that, it therefore means this is going to change to sine 2y. That will change to sine 2y. Then, the reason why we converted there, we cannot perform, it was not possible to perform when we have a term on the denominator. We would use the quotient rule, but it was going to be long. Then plus ln y, it can be differentiated as it is. Then we take minus e to the power a negative 2y over 4. That one can be differentiated. Then it's saying plus 5 to the power 3 pi y over 2. Then minus p. This is raised to the power 0. Any number raised to the power 0 is 1. Then it's going to be plus 6py. This is what we are having. Then we convert, because this one cannot be differentiated, we need to put it on the numerator. So our x is equal to y to the power a negative 1 over 3 minus sine 2y plus ln y minus e to the power a negative 2y all over 4 plus 5 to the power 3 pi y all over 2 minus 1 plus 6py. Then from here, you can start differentiating, because everything is in a format that it can be differentiated. Therefore, it means that from there, we can now determine dy dx. So it would therefore means that the dy, the dx, dy will be equal to, if we are to take this term, let's take this term as it is, applying rules. Applying the rules, it means we are going to apply what? It means we are going to apply this rule here. It means we are going to apply this rule here. It would therefore mean that we'll bring down, let's go, that one, it will mean we have to bring down our n, multiply the coefficient. This is what we are going to apply to simplify that. So applying that there, it means we are going to get a negative 1 over 3 Okay, let us do it this way. to simplify this one only, to simplify that only, the first term. So we are saying we have the coefficient, it multiplies the power, which is a negative 1 over 3. Then we have x to the power a negative 1 over 3 minus 1. If you check, this one is going to simplify to minus 1 over 3 x to the power a negative 4 over 3. Then we are done with that one. Then to simplify the second one here, we can apply the chain rule. How are we going to apply the chain rule? So we can take, how are we going? So we can take that the only part is y is equal to minus sine, let me put x, not y. We can only concentrate on p. Okay, p is there, avoid p. Let me just use another term. We can take it as t is equal to minus sine 2y. Then we say let 2y, let u be equal to 2y. Let u be equal to 2y. So du dy will be equal to 2. Then it means the t will be equal to a negative sine u. So dt du will be equal to negative. If we go to the formula sheet, it's saying for sine x. So it means we are using this one. The derivative for sine x is cos x. If you differentiate sine x, you are going to get cos x there. So using that, it means this will amount to negative cos u. So dt dy will be equal to dt du multiplied by du dy. So eventually dt du, we found it to be negative cos u, but our u is what? Negative cos 2y there, which is going to multiply what? Which is going to multiply a du, which is 2. So this becomes negative 2 cos 2y. So it was possible, if we understand from here straight, to just know this, deriving this, it comes out. So it means this was going to give you a negative 2 cos 2y. Then we go to our formula sheet. We are having ln y. There it is. If you are differentiating k ln y, here it is. It's saying k ln x. Here it is. If you are differentiating k ln x, it's going to be k over x. But in our case, the coefficient of ln x is 1. So it means to do the third one, here, it was going to give us plus 1 over y. We go to the next one. On the next one, you can still apply. the chain rule. How are we going to do that? You can just say, here we are now on this term, let the t be equal to e to the power a negative 2y. Here we are having our negative quarter there. So we are going to say let u be equal to negative 2y. So du dy will be equal to a negative 2. Then the t will be equal to a negative 1 over 4 e to the power u. And we know dt du will be equal to that one will be equal to a negative 1 over 4 e to the power u. So it will mean that dt dy will be equal to dt du multiplied by du dy. So this is going to give us a negative 1 over 4 multiplied by e to the power u, but the u is what? The u is a negative 2y multiplied by what? Du dy, which is a negative 2. So eventually we end up having a negative and a negative positive 2 over 4, which is positive 1 over 2 e to the power a negative 2y. So that one is going to give us here, when you differentiate, we are going to have a positive 1 over 2 e to the power a negative 2y. So take note there, this one would realize that it just needed you to bring down the negative 2 there. So it becomes positive, then positive 2 over 4 e to the power a negative 2y. When we come to this one, we have to know that when dealing with exponents, it's easy when the base, it's easy to apply differentiation when our base is going to be e. So in this case, we are having this question here. It's a bit slow. So let's take out this. Let's take out this. Yo. Okay, it's fine. So it will be easier if we first convert this to exponential. So to convert that, we can just concentrate on, let's do that. Together we are now on this term. So we are having that term which we can now write as This term we can now write it as 5. Let me write it 5. Or the coefficient is 1 over 2 there. So let's say our t is equal to 1 over 2 there. Then we have 5 to the power 3. 5 to the power 3 pi y. So this is what we have, but we said it's easy to do with exponential when the base is e. So on this exponent there, we can just simplify that. So let's say using that. So let's say that exponent 5, 3 to the power 3 to the power pi 3 pi y, let it be equal to e to the power m. Then we calculate the value of m. Let's calculate the value of m there. So it means we introduce natural logarithms both sides. So ln 5 to the power 3 pi y is equal to ln e to the power m. Let me write it properly. Ln e to the power m, which means this m will be which is equal to m there. So in other words, we can say this term t can be written as 1 over 2. Then where there's 5 to the power, we write it in terms of an exponent. It becomes e to the power. We said our m is equal to what? Ln let me just we bring down the power here, so it's gonna be 3 pi y 3 pi y ln 5 there. It becomes, so let u be equal to that exponent, which is, we can write it as 3 times pi times ln 5 there times y. So it will mean that du dy is equal to 3 pi ln 5. Then it means your t is equal to half ln, half e to the power, not ln, half e to the power u. So it means dt du will be equal to half e to the power u. So when you want dt dy, this will be equal to dt du multiplied by du dy. dt du, we found it to be half e to the power u, but our u is what? 3 pi ln 5. Multiplied by du dy. Where is du dy? Du dy, which is 3 e which is 3 here, which is 3 pi ln 5. So if we are to simplify this, if we are to check this whole part here, let me write here, this whole part here, we found it to be this part here, which is 5 to the power. So when you simplify this, it's going to give us half times 3. So we are going to have our answer is 3 over 2 pi ln 5 multiplied by what? Multiplied by 5 to the power 3 pi y, like that. So eventually it means here it's going to be plus 3 over 2 ln 5, 3 over 2 pi ln 5 multiplied by 5 to the power 3 pi y. You have to take note where we put this 3 pi y, you'd realize that some texts will be having e to the power 3 pi ln 5 here. Then the next term we see it's a constant here, so we get 0. Take note here when we're doing, it's not x there. Sorry for that. Yeah, it's a y. Yeah, it's a y. Then here we said we differentiate a constant, we get 0. Here we are going to have plus the derivative there is gonna be 6p. So this becomes the answer. This becomes the answer for that question. Then we move to the next question. We move to the next question. What are they saying on the next question? Here they are saying use the quotient rule. Use the quotient rule. By using the quotient rule, differentiate y equal to quot x. Let's go and do it down there. They want us to differentiate y equal to quot x using the quotient rule. And that's question 4.4. So here it's now freezing. Okay. They are saying using the quotient rule, they want us to do, let's use this one, y equal to quot x, differentiate that with respect to x. So here we know quot x will be the same as y is equal to cos x over sine x. You can use that one. And using the quotient rule, it means let's let u be equal to cos x and v be equal to sine x. So using that, we can go here. If we check where is our quotient rule, here is our quotient rule. Take note of the formula that we are going to use. Here is our quotient rule. If y is equal to this is our quotient rule. Say v du dx. So in other words, let's go. It means using quotient rule, dy dx will be equal to v, which is our denominator, multiplied by du dx. Subtract u, which is the numerator, multiplied by dv dx all over x all over v squared. We just extracted that from the formula sheet. So we found our v, it's what? Our v, it's what? Our v, it's sine x. Then it's multiplying du dx. This is our u. So it means du dx will be equal to, we just go to the formula sheet. If we go to the formula sheet, if it's cos x, the derivative, it's negative sine x. There it is, here. Here it is. Our y is cos x, the derivative is negative sine x. So just go and substitute a negative sine x. So it means we're going to put here a negative sine x. Then it's gonna be minus u. If you check u, it's cos x. Then what is the derivative? What is the derivative? Here you come. What is the derivative there of sine x? So in other words, dv dx. Here we extracted it to be negative sine x. You just go to your formula sheet. If you go to your formula sheet, here it is. If you are having sine x, here it is. If you are having sine x, the derivative is cos x. So you just go here, you put your cos x all over v. V is sine, so it's all over sine squared x. So if we are to simplify this, it's going to give us what? Let's simplify that. It means it's going to give us this times this. It's gonna be a negative sine squared x minus a cos squared x all over a sine squared x, which is going to give a negative. Then we have sine squared x plus cos squared x all over sine squared x. But if you are to check on the formula sheet, we found sine squared x plus cos squared x is 1. So it therefore means, here it is, it therefore means here we end up having We check here. So here we said here we end up having, here we end up having cos x. So it will mean that here we are now going to have this will be equal to a -1 there over sine squared x. But we know 1 over sine squared x, if you still remember, we have the identity which says 1 over sine x is equal to cosec x. So it will therefore mean that this is going to turn to our final answer here is going to be equal to a negative cosec, gonna be a negative cosec squared x. This becomes our answer. And if you are to check cot there, it's negative cosec there. But now, alternatively to that question, it was possible to do it in a different way. It was possible to do it in a different way. If we were to check, we are going to start from there. So we are saying O. It's saying Y, but we know this can be written as Y equal to 1 over tan X. Then we let our U equal to numerator. So we are going to let U equal to 1. Then V equal to tan X. Then you copy. This is the formula for quotient rule. So our V is what? Our V is tan X. So it means this was gonna reduce to tan X. Let's do it. So it will mean that dy dx was gonna be equal to our V. But in this case, our V, remember we said our V must be the one on the denominator. It's tan X. Then du dx, that one. So it means if we wanted du dx here it's a constant, it was going to give 0. So here it was going to be multiplied by 0 minus u, our u is 1, multiplied by dv dx. You go to the formula sheet, then you check the derivative for tan. If you are to check, they are saying tan is given as is there on the formula sheet. Here it is. They said it's sec squared. They said it's sec squared x. So we use that. They said it's sec squared x. So here we mean that dv dx is equal to sec squared x. So it's gonna be 1 multiplied by sec squared x all over v squared. Our v is tan, so it's gonna be tan squared x. If you are to simplify, that was gonna be equal to this 0. These ones are multiplying. So sec squared, which is negative sec squared x divided by tan squared x. Sec squared x means what? Which is equal to sec is 1 over cos. So it's 1 over, which is negative cos squared x divided by tan x. We have to know that tan is sine squared x divided by cos squared x. If we are to simplify that further, means that was gonna give us okay. So if we are to simplify, this will be equal to a negative 1 over cos squared x. Here multiply this one, reciprocate, it becomes cos squared x over sine squared x. If you check now, this denominator and this numerator are the same. So our answer, we are left with negative 1 over sine squared x, which is what we got there, which is going to give us a negative cos x squared x. Right. When you come across this, don't forget to subscribe and share.